That's 2 meters. That's 5 meters. We'll just go with that. And then I need a switch, but I don't know how this switch is supposed to work. Because the filament's gonna go. I don't get it. The switch don't make sense to me. So they're using this. So can I copy this image and throw it in AI? Copy image. Paste. Yes, it's not working. Okay, let's do this. Snip. New. Copy. Okay, why is my computer control? Huh? I'm confused. Or why? 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 Yeah, that's a generic part number. Huh. How do I want to fix this? That is the $1,000,000 question. Because I remixed it to this guy. And this guy did what? Switch a fuse holder input socket. Okay, that's fine. It is important that the limit switch assumed by Arduino based system with logic, those specified are not simple NC or NO switches. What? What is this? Easy electronics alternative for LTS re-spooler. This is the mostly aesthetic, very pleased. Yep. Yep. Okay. It covers the open wiring on the filament. You need to switch the 6mm bolts out for 8mm bolts and put in over the limit switch. The original LTS design. This is alter a bit simple switch. In my case, made it a bit unsightly. Okay, so what is... I'm so confused. I'm going all over the place with this. It's like a remix of a remix of a remix, but what switch? I don't get it. Bamboo Labs Allen key. It still doesn't say. I'm confused. It still doesn't say what switch to use. Because I don't know what switch that is. Like, I get the concept of the wiring. I don't get it. This is way above my pay grade. I don't get it. I was able to get a normal 3D printer stop switch to work for the auto stop feature. I actually pulled it off of one of my old printers. If you connect the two outside pins to the switch, to the stop, and the ground pins to the controller, it will stop the motor when the switch is open. Though you might want to test. Yeah, that makes sense. Make sure the parameter's laid. Okay, but how do you connect? Again, it doesn't make sense. Okay, here we go. It is necessary to use such a limit switch, as well as a 4mm steel ball. The limit... Okay, so this explains where the ball came from, which is why I don't know where the ball gets used. The limit switch needs to be slightly modified, namely by breaking off the steel plate and removing all resistors and diodes and connecting the wires directly to the limit switch. Okay, that makes... I can get behind that. But I need the part. At least there's an AliExpress link. Hopefully it works. And it's actually in English and not whatever this is. A B case limit switch. I don't understand. What? Let's try that. Something tells me that's not going to work in cross-reference. Paste. Go. Nope. Didn't think so. Not that lucky. Okay. Copy. So that's them. But I really don't want to spend that much money when I only need one switch. And it looks like a standard limit switch. The difference is just the mounting hardware. I guess I can always unsolder said and solder it directly to the wires and just use the board to secure it? Question mark? Or go with something like this. But the problem is it's not 90 degrees and it doesn't have the mounting holes, so that wouldn't work. But I think that would. So what is this? That looks like the same thing. Like, that's the physical switch. What am I missing? I guess I'll go with 2 of these. We'll be here in 2 days. Add the cart. These are not going to stop me from building. So let's get these ordered. Go to cart. Proceed to checkout. Change to my name. Change cards. Use the payment. It'll be here tomorrow. Sure. Don't really matter. But I'll make them waste their time and money. Okay. Parts were ordered. Let's see if we can't build. Okay. Oh. I guess first things first, let's work on electrical components. Not really sure the plug is needed, but I'm gonna put it on there anyway, just because I have it. Lock washer. Is there a flat washer is in here too? No. Nope. Okay. Fine and dandy. Fine and dandy. Why do I have two pulleys over here? I don't understand. I only broke one. I'll deal with that later. I'm squirreling it. Okay. Case. Side case. That should fit through here. That looks awful small. Ain't no way that's gonna fit through there. What the world is this? Oh, whatever. Guess we'll drill that out to make it bigger. So let me go grab the drill and drill bits. Oh. Let's go 3/8. That's going to be too small. Half. It's probably too big. Let's start with 3/8. See if that fits. Does not. It might. It might thread in. Let's see if I can thread that in there. Nope. Not gonna. It's not much. It doesn't need to be much bigger. So. Waller that out a little bit. Come on. Okay. Looks good. It's probably good enough that I can get that in there. Yep. It'll thread in. Broke it. Pulling it off the supports. Just super glued it back together. It'll be fine. Okay. Looks pretty kosher. And then oh, I was meant to put the nut on it, or the cap. That ain't gonna happen. Nut. So now we're putting lock washer and lock nut, or the nut, capture nut, on the back side. Okay. It's gonna get me close. I've done something to my finger, my index finger. I don't know what I did to it, but it hurts. Whole thing is moving. We're good. That's nice and snug with a bug and a rug. Then I need the controller, which is in this bag, in this box. This does not look right. I'm confused. Why? Why does everything have to be so complicated? No, this is right. All three dip switches set down for 32 division. What's 32 division? I don't understand. But I'm gonna turn them all down because that's what they have. And then input control signal is gonna go over here. Heatsink, adjustable current. That says, oh, that's an isolator, yeah. Power indicators there. Then power is this guy. So I'm gonna run power. We should make sure this thing actually fits. It should. It's gonna be a tight fit, but I think I can get that in there. Okay. So this is gonna go through here directly into this guy. So let's grab our screwdriver. And then I'm gonna cut this back to about there. I need some like, oh my god, my brain's not working. I need new wire strippers. I need a lot of stuff, honestly. Go about right there. Should be some pretty small wires. So let's go with 20. Let's go with 22 gauge. That looks. It's not labeled. It's probably 20. Ground and voltage. it's going to go voltage and ground. So voltage is right, ground is left. That's going to go like so. Oops. This is why I cut this short, is I don't want all the extra wire in this cabinet, but you kind of have to. Voltage. Voltage is this way. Ground is top. Yep, that looks right. Shove those in. Tighten these guys down. Okay. That. It's gonna give me that. So that gets me the controller. Now, how does the electrical work? I'm confused. How does the motor mount? That's the part I don't understand. How does... Go back and look. Uh, input control signal. Connect to stepper motor A, B, B. Well, I don't know what... Again, I don't know stepper motor language, so maybe that's where I'm getting confused, because it's saying connect the stepper motor to the pins down here, which is fine. I guess I just need to look up stepper motor pin set to figure out which is which I guess I can do next. So we'll do that. And how's this oriented? They have this oriented so that the back, so the stepper motor comes out, the wiring comes out the rear and folds? That doesn't make any sense. There's no way that that fits like that. Because it's going to get twisted. I'm confused. It can't go that way. Even though that's what they claim it is. What? This is an alternative method. Tie the fan positive with the switch output to the positive connection of the controller. Tie both negative connectors to the controller connector. Okay. I mean, I guess I could do that. I can run the fan into the input with that. That's fine. I don't agree with this problem, because if this fits like so, and this is going to fit like so, which should fit in there, which is like that. And this is going to have to go in underneath it. So if this goes in under and secures like this, then how does this mount on here? Because that's not going to close. So clearly this has to get rotated to the side. There's room either way. I guess I'm just going to have to not cut a notch in the triangle to make that fit, which I guess, sure. So we'll come out this way over. Then I got to mount the fan, which I don't know if that's the right fan. It does not look like it is. It's going to be this little guy. Which those wires are not going to be long enough. That's a problem. I guess I can rob some wire, solder it on there, extend it, make it work. That's fine. Yeah, that's fine. We'll make it work. One way or another. We'll make this work. I gotta figure out which way this fan needs to orient now, because I don't remember. Fan should blow. I don't know. So magnet on the inside. Yep, magnet on the inside. So that's going to mount like that. I might be able to make that reach if I stretch this a decent amount. Oh, well, I could do it. Let me try it without it first. Okay. Then I'm going to need this guy. With the smallest gauge wire. Strip just to tick off. A little more than that. There we go. Those look okay. I think I can get this in here and then weasel it back at the same time. So let's undo positive lead. Sure that's not coming loose. It's not. Negative. Negative. The reason why I'm doing it this way is because then no matter what voltage I set the output, the fan still gets 12 volts feeding to it at all times. So that's why I want to put it on the input side of this. So I can shove that through the box. Okay, that's that. I'm gonna need to shorten this wire as much as possible to make this work. So let's go with... I need to fix this problem first. Let's secure this guy. To do that, I'm going to need to break off somewhere about right there. It doesn't have to be a whole lot. Something like that. I don't know if I can get it with scissors, but I'm going to try. Oh, shit. That was way too easy to cut. Or did I just break it and not actually cut it? Which, that's probably more accurate. Okay, let's try this. Okay. That looks fine. There we go. So now that should fit like so, which it does. It's going to give me room that I can bend the wire backwards. I can bend the wire this way, get me to the controller, which is fine. Put this back over this guy. Then this is going to come around over. I'm trying to make it as short as possible, but still have wiggle room. Let's go with there. So the other end. So, stepper motor, wiring diagram, 4-wire. Black, green. I'm confused. Red, blue, green, black. Okay, so this gives me all 4. Red and blue are A. So one side of this is A, the other side of this is B. Okay. We're getting somewhere. Don't know what size wires these are, but let's guess. We'll start with 16. Nope. 18. Nope. 20. Nope. Nope. 22 gauge. That seems way too small. Yeah, I guess that's right. 22 gauge. 22 gauge. Okay. So now I need to get wiring to all of these. How can I do this without this being a complete disaster? I feel like that's got to go that way. I need to get to it from this angle. Okay, that's what we're going to do. So A positive is red. So that's going to get shoved into there. Snug her down. Okay. Blue is A minus. Green is B plus. B minus is black. Broke the green one off. That's great. Okay. That's that. So that gets me power. That gets me stepper motor. That gets me my fan. That's pretty much all I care about at this point. So that's going to go in upside down. Because it's going to go in. Why? Why does it not fit? I'm so confused. This fit before. Okay, I'm confused. Oh, it's the wiring. It's adding thickness and it popped off. Crap. This is gonna fight me the whole way. So what's gonna happen? Might have to bust out the Dremel. Come on. Need another hand. That's what I need. This is a nightmare. Nightmare, nightmare, nightmare. The wind is picking up outside. Let's try this again. Green popped out. Again. that's that. Let's try this again. If this pops out another time, then I am going to grab the Dremel and we are going to force these wires. It is so tight. Come on. Come on. You're in. Come on. Come on. Go in your hole. Come on. You can do it. Well, I'm going to break this case is what's going to happen. They said it was going to be a tight fit. I just didn't realize it was this tight of a tight fit. What's going on, Swedish Forge? If I keep fighting this, yep, I'm gonna abandon it. We're gonna grab the Dremel. Because if I keep doing it, I'm gonna break it. Let's try this again. Ow, my foot. This is gonna make a mess. Gonna get loud. Actually, wasn't that bad. Let's try this again. Why is this putting so much pressure on this case in the wrong direction? That makes no sense. Because I had this in here before I put any wires on it. The only thing I could think of is just the wiring is just getting pinched. It's got to be. We'll keep grinding. Yep, that's what we're gonna do. Turn her up a little more. Okay. Took a lot more off. Let's try this again. Besides the wires just popped off, I can deal with that. I'll just have to pull it back out and re-put them on there again. But why in the world does this not want to go? Okay, so now I got it in its hole. Can I get to these set screws? No, I can't. So I have to get these on there before I put this controller. Ugh, this is such a pain. Let's try this again. B minus is black. Make sure I have this right. A plus is red. A minus is blue. Yup. B minus is black. I really feel like this is not enough wire. And that's some of my problems that I'm fighting. Like all of these wires are coming off. Yeah, they're all popping off. Let's redo this whole process because I'm not happy with how this is working. And I'm about to solder them directly onto this board. Probably would have fixed most of my issues, but whatever. Hindsight, I guess. So B, red, blue, black, green. B minus. I choose you. I'm going to go all the way to the point where even the rubber sheathing is going to get pinched to hold it. It's not ideal, but at this point, I don't really care. A positive is red. So let's go with this guy. Shove you all the way in. Tighten you down. Blue minus is, or A minus is blue. There's not enough wire on this. It's like it's only got like 4 strands of wire in it. I feel like it's half my problem. Blue. I know for a fact I had the B leg of this switch wired incorrectly. So, kind of glad it broke. For like the 5th time, because I kept doing it incorrectly every time. And green. Okay, let's try this again for the umpteenth time. There we go. I'm not putting it all the way in because I can't. Not yet. That should reach. It barely does, but I'm fine with that. Okay. So then this is going to go in like so. And I'm fine with that. Let's do a functionality test before we go too far. I need my 12-volt power supply, which is this guy over here, which is for the carousel. I designed this to use the same power. I have a fan. Yep, it's working. You guys can't see. Let me turn it around so you can see. So, fan's running. And now I have voltage. And then if I move that to counter or clockwise, it's barely moving, but it's struggling. And I'm assuming it's struggling because it's on no voltage. That sounds terrible. What? That should not be that bad. That tells me I have a wiring problem somewhere. Because I'm assuming something tells me it's a continuity. Okay, this is way out of my element now. I'm assuming you can hear this. Like, it's not spinning. Try the other direction. It's the same problem. I don't understand. Unless my wires are incorrect. Or this stepper motor's junk. Which I wouldn't be shocked. Because, like, it wants to turn, and then it stops. I don't get it. I don't get this at all. Could it be a dip switch problem? Or I have the wiring incorrect for this stepper motor. That would be the only two things I could think of, or I don't have enough voltage. The first line displays the rotating speed in RPMs. The second line displays a time or a loop time which can be set. Press the CW button for clockwise and CCW for counterclockwise. Press the run stop button to start or stop rotation. Rotate the potentiometer, change forward and reverse speeds. Yep. That makes that makes sense to me. Like, so the bottom is a clock, the top one's your RPMs, counterclockwise and clockwise. Okay, this is clearly not working. So let's look up. I think this is a NEMA 17 because maybe I have the wrong directions. NEMA 17 stepper motor wiring diagram. Okay. Red, yellow, black, orange. That doesn't help me none. Oh, 4-wire. Red or blue and red. Coil A. The motor's rotational depends on the wiring order within each coil. I'm so confused. Let me go to Amazon. Something tells me I ordered the wrong part. Or I have a defective one, which is a high probability because that's my luck. NEMA 17. I'm looking right here. It doesn't say which is which. Oh my god. What's interesting?
Hello, today we are going to talk about wiring 4-wire stepper motors with a Buildbotic CNC controller. In this video, you will learn some easy tricks. Table has phase A on yellow and purple and phase B on black and red. Now that you've determined which motor wires are in the same phase, connect them to the phase meter and set it to measure resistance. Then connect the leads to 2 of the motor wires. If they're in the same phase,
I guess that makes sense.
the meter will measure a small resistance. If there is no resistance, they are not in the same phase. Here's a handy trick you can use even if you don't have a datasheet or a multimeter. Hold 2 of the wires together and try to turn the motor shaft. If the wires are on the same phase, it will be harder to turn. So, how does this work? When you connect 2 ends of a phase, you create a circuit. If the shaft is then turned, the motor acts like a generator that powers the circuit and produces a magnetic field. This magnetic field makes the shaft difficult to turn. When you connect two wires...
I can't do it that way because that's a 4-pin plug and that's a 6-pin plug. Oh my good grief. I keep opening up cans of worms. That is aggravating as all get out. Okay, voltmeter. Horseshoe mode. I mean, I guess it doesn't have to be continuity. I could just do continuity. Yeah, I can do continuity. Let's see if we can't figure this out. So, pins 1, so red and blue and green and black. Yeah. Unplug you. Red and blue and green and black. Red and blue, green and black. So I have it right. Unless it's backwards. I'm so down a rabbit hole that I am not comprehending. So I don't get it. A? What? I'm really at a loss at this point. A, B, A. So A. What? Positive, negative. I'm struggling. A and A minus. So A is black and green. So black is positive. That would make sense. Let's try swapping these two phases out for the B. Because green typically does mean ground. Well, I guess it depends on how you're looking at it. But in this situation, it makes sense to me to flip them. So to flip them, we're going to shove that guy in there. I don't know why I'm fighting with this box. Oh, it's because of the power wire. That's why. That's not going to stay. We're going to try it. Green goes in the negative. Oh, hey guys. I'm on the struggle bus. That's all there is to it. I am way out of my element trying to figure this out. And I am getting very frustrated because I'm so lost. So let's try this and we're going to see if this works. So let me move this around so you guys can see what's going on. Trying to stream and for me to see and for you to see and everything else. It's not easy. So, okay. Power. Have power. Yes, I have power. So right now, it is programmed for 60 RPMs. Yeah, it's doing the same shit. I don't understand. Jack, you might be able to help me with this. It doesn't matter what I do to the RPMs. And it doesn't matter which direction I go. It just clicks. And it tries to turn. But this is all it does. Like, there you go. That's what the stepper motor does. And I've confirmed that it's connected to A positive, A minus, B positive, B minus. I've tried flipping the B's because I don't know which way is which. And the stepper motor just sits here and I don't know what to change. That's the problem. Okay, let me turn this off. The only thing that I can change is a dip switch on the back. Hold on. Let me pull you up the directions that came from this guide that they wrote. So these are the things that they've done. And they're going to tell me solder, blah, 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 blah. Sure. My parameters I use for the controller, all 3 dip switches set down for 32 subdivision. So the dip switch 1, 2, and 3 are down, which I've already done. Let me disconnect the power before I fry something. So let's dip them up, and then I'm going to move them back down. So all 3 are down. And then I guess I need to change all these parameters. Which I guess I could do. It's not that hard. I just got to figure out how to do it. Okay. Plug you back in. Okay. How do I navigate this son of a gun? That's the next question. Okay. Parameter interface. Rotate the potentiometer to change parameter, then enter. Okay, well, how do I get into the mode to change that? Is it the center button? Hold the center button. There we go. Okay, so now we're smoking. This controller only does I don't know. This is foreign language to me. So it's saying PO1 is in P3. PO3. That is correct. FO2 is 1600. That is correct. FO3, they have it as it's 135.1. So that is the forward rotating speed in RPM. Wait a minute, that doesn't make any sense. FSO3, that's going to change based on what input I put into it. Right? I think. Let's find out. So let me change if I change the RPMs, let's just say 118. Now if I go back to 3, yeah, that's 118. So that's set based on the wheel. FO4 is 1600, which is what it's set here. FO5, they have as 999.9. What the fuck is that? Reverse rotational speed in RPMs. Okay. Is there a faster way of going to infinity? Probably backwards. Because I'm at 60. Da, 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 da. Go, go, go. I'm down to 30. There's got to be a faster way of doing this. There we go. I'm an idiot. That's all that comes down to. It's fine. 999.9999. Okay, there we go. So FO6, they have a 0, and I have it as 1. So FO6 is cycle work time. -- means infinity loop. So I need to change that. How do I get to -- when 0 is as low as it'll go? That's a problem. Okay, I guess I just crank it up. Okay, there we go. Problem solved. FO7. FO7, according to the manual, is forward in position delay in seconds. FO7 is 0. Okay, that's fine. That's where I'm at. FO8 is 0. FO9, they have it as 200. FO9 is pulse numbers for 1 revolution. Unit is 10. So example, if stepper argument is 1.8 and the subdivision is 8, so that the pulse numbers for 1 revolution is 360 degrees. Divide that by 1.8. Times that by 8 equals 1600. So the set value should be 160. They're saying 200. This is probably my problem. How do I fix this? Uh, 200. Oop, let's go there. 200 set. F10 is 0, and F10 is set to 0, so that's fine. That is going to be the set the LCD parameters for RPM, whatever. F11, set the motor work state to run stop. 0, slow down and stop, or 1 to immediately stop. I might change. No. We'll leave that to stop and. Well, wait a minute. What is it on now? 11? Slow down. Okay, that's fine. F12 is set to 20. Default is 50. Set the acceleration, deceleration level. Okay, so I guess we're going to slow this down a little. It's going to go down to, would they have it as 20? Okay. Set. And then F13 is 001. And that's set already. So there we go. Okay. So hit and hold. Turn that off. Okay. Let's try this again. Is the trim pot set right? I don't know. English. That is not English, sir. So you're saying crank the current? This guy? The picture looks to be in the same orientation as that, but that doesn't mean shit. It doesn't say anything about cranking it up either. Okay, let's try this. I mean, I did make some changes. Plug you in. And then start. It's still fucked up. Yeah, it's still doing the same shit. It's trying, but it's like it's lost. Like it's okay. Well, you guys can't see shit. Might need more amps. That makes sense. Oh, I just lost full. How did I just lose continuity to this guy? Like it just shut off. What did I lose? I'm confused. Did this thing just die on me? I don't know what I'm doing. No, it was getting a little warm. Yeah, when it was functioning, not hot. I wouldn't call it hot. I could still hold it, but I've never got it to work. So, when in doubt, crank it up. That what you hear now is just the standard 30mm fan. Yeah, it's still. Let's turn this guy way down. Okay. Crank you up some more. That's as far as it goes. And it's still just clicking. Oh, wait a minute. Maybe it doesn't like running slow? mean, is that 300 RPMs per minute? I don't know. Oh, it didn't like... It doesn't like... Oh, wait a minute. On reverse, it's $9.99 and it spins like crazy. So it runs just fine in reverse. Like, that's smooth as all get out. I don't know which direction this needs to go, but I guess I could just run it in reverse. This is so weird. Like, that's smooth. This thing's not getting hot. And it's a 999.9. What if I turn this down? Let me try like 300. Oh, as soon as I get down there, it starts wigging out. Like, it is not like anything slow. Yeah. 700. That seems awful fast. I don't get it, guys. I don't get it. I wonder what people are actually running this at. That's the next question. Somebody's calling my phone. It's probably the wife. Nope. International caller. You can kiss my ass. Oh, wait a minute. Here we go. Not sure what is wrong. Film ejector switch doesn't work. Stepper motor works half the time and only in counterclockwise direction. When it does work, it works for 5 seconds and starts stuttering. Okay, so they gave me an update. Okay. Hallelujah. Let's try this. I'm going through the notes. So they're saying black wire. Fix the issues of the stepper motor. Wiring is incorrect. For those who runs in the same issue, wiring is as followed. Black is supposed to be... Oh, these are all fucked. I hate that. I hate this wiring with a passion. This fucking wire is the shittiest, cheapest, crappiest. I mean, I don't think. Yeah, it's bad. It's bad. So they're saying black is supposed to be a positive, which is supposed to be the first guy. So this is supposed to be black. A minus is supposed to be green. I mean, if they put better gauge wire on here, it'd probably fix some of the problem too. Oh my god. This wire is so bad. so bad. Oh, for fuck's sakes. Okay. Start over. That's how bad this wiring is. It is such the thinnest, crappiest gauged wire, and I'm about to just solder it right to the controller. Still waiting on Jack to send me new wire strippers. Okay. Let's try this again. I'm sure somebody makes a connector for these. I probably have them, and I'm just being really lazy. But I might bust out the Futaba connectors and get the pins and just pin this. Probably would be easier in the long run. Who am I kidding? So black goes there. Green is next. Come on, stupid wire. Okay. Then red is B positive. Wait a minute, did I do this right? Green A minus, black A positive, red. I need B minus. B minus, B minus is blue. B minus is blue. Okay. I choose you. Go in your home. All the way in the home, thank you very much. Okay. You feel pretty good. And then B positive is red. Go in the home. Please. Thank you. No, no, yes, no. Oh my god. Okay. Filament limit switch still doesn't work. I don't even have one, so I'm not worried about that at the moment. Need better clarification. Latest update. Fuck it. Got rid of the filament detector switch. It's more than trouble than it's worth. I'll come back. Yeah, blah, blah, blah. That's fine. Okay. So, for shizzles and giggles, I'm not even going to try wiring this all right. I just trying to get this stupid thing to function. Power. I now have power to said controller, but before I go cranking on this thing, let's turn it way down. Because I still think the way the gearing and stuff is, I think most people run in like 100 or 200 RPMs. It does not need to be fast. Holy shit. It's working. You're saying crank on it. Well, let me put it together first. Give me a minute. We got a victory. It's working. Unplug you. Shove you through here. I'm going to break this. That's what's going to happen. I can already see it now. I'm going to get pissed. I've already broke this case once. There we go. Not going all the way in with it. Not yet. Not yet. Not yet. Patience. Patience, guys. Patience. Okay, you guys probably can't see shit. I need... What did I do with my screws? Did I leave them inside? I did. I'll be right back. Yes, I would have liked to have printed this, by the way, in green. I did, yes. But the directions that I was reading everywhere was telling me the other way was the correct way, not this way. So, whatever. I don't care. Gotta mount the motor. Or attempt to mount said motor. That is not the right fucking Allen wrench. Oh. No, it's not. Why? Why does this have to be so complicated? Why? I had a rough day at work today, by the way. So this isn't helping. Oh, these are too long. Oh, good God. Way too long. These are not going to work. Okay, well. Are these long enough? That's the next question. Now I need that big ass Allen wrench because we're back to this size. And then, God forbid, whoever designed this made these holes relatively the correct size, but instead they made it 5 times larger than it needs to be, which forces you to use washers because that's a great idea. Holy shit. Something's working right. Not. There we go. One more. Oh, fuck you. Okay. That's that. That gets plugged into here. Like so. Then I'm going to fold the wires behind it, which is fine. Everything is fine. Everything is fine. Put that together. How does this secure together? That is going to be just some standard 3mm hardware. So now let's go back. This is a bad idea. This is a real bad idea. Why does that not go in the countersink hole? Oh my god, who designed this piece of shit? I'm losing my sanity because nothing wants to work right. Trying to be proactive and use better hardware, but no! Button heads don't work. Good grief. I'm losing my shit. They actually had 3D printed washers on here. Yes. I laughed. I laughed comically, actually, at that. I'm going to ban you for saying that again. Yes. Should I go really long or really short? Because I don't have the correct size, and I don't know what it's going to take. I feel like the long ones are probably going to make this a little bit more secured. I just don't know how long these threads need to be. Please go. Hey, it fit! It's like they designed this around the cheapest components and parts possible. Like these, I'm telling you, these are like cheap aluminum. I don't like these Allen heads at all, but I guess if I'm going to use them, this is the project for it. Because I'm not going to use them on an RC car. I'm going to tell you that right now. These are way too long. Okay. So that gets me... Yeah, these are like double the length that they need to be, but it's fine. Let's put some of the smaller ones on the fan to get the fan secured. Magnet goes on the back. Is it even going to reach? Probably not. That's my look. It's so close. Let's just cram it and hope for the best. That's what she said. They don't fit. Oh my... God, this is such a terrible design. Who in their... I'm losing it. I'm losing it. Will these reach? Probably not. No, they will not. Okay, well, long ones. Where did you go? This is such a terrible idea. And then a stupid nut. Because this makes perfect sense. I'm not putting 4 of you on there. That's pointless. You're going to get 2. Just because I don't want to waste the hardware. There we go. Okay. That gets closed up with this guy for the time being, which is going to go like so, but it doesn't fit. There it goes. I'm like, why does it not fit? I would use button head screws. Something tells me they're not going to fit in that stupid hole. So we're going to use these little guys. don't know if that worked, but that might have stripped it, but whatever. It's working. Anywho. Okay. Now I have a fully built electronics box that will fit this guy, which I don't have all the parts, and I broke it putting it together, so I can't completely do a function test, but this fits basically here. You guys can't see shit. It's going to fit like so. Then there's a gear that mounts like so. That's going to go around an idler, around this gear, which then spins, and then some other stuff. And then there's another gear that goes up here somewhere that spins and does some more gear stuff. Oh, it's full blown missing. It's missing. Trust me, it's missing. But it's not. It's this controller is built, and that was my function. This is my goal, was to get this done today. So now the stupid wiring is rubbing the fan. For F's sakes. Why? 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 Sounds like a little like two-stroke weed eater over here. Like taking forever to spool up. Like it's going. I didn't touch any. There's no wires rubbing. It's rubbing the plastic. That's what it's doing. This case. Oh my god. The case rubs the fan, and it puts pressure on the fan. Okay, fuck you. Problem solved. There to there. I can't see that. There to there. I can see that. What? Oh my god. How? Oh, it's because I didn't go far enough. I didn't go far enough this way. It's close. Understand. Let's go a little farther. I don't know what to do to this. I'm gonna call it done. Hopefully it just self-clearances itself. That's what I'm hoping for at this point. I don't know. Whatever. I'm ignoring it. You don't know why I'm ignoring it? Because it still functions. So it's going to mount somewhere like so. This gear gets mounted. Something like that. Holy vibration, Batman. Like, it's the motor, stepper motor smooth. It's just harmonics of plastics. Because something is clearly not designed right, but my bet is I'll never run 300 RPMs. Because that sucker is moving. And to show you what I'm trying to build, let me see if I can find you a video. That's what I'm building. I'm just curious on what speed he's running it at. Oh, he's running it at full speed. That does not sound like the video I watched. So if mine sounds like that, I'm gonna ignore the electronics because I'm not gonna hear the electronics vibrating. Because that's loud. Really loud. Something tells me he's not. Something's not kosher with that. Okay, you're annoying me already. Here's the official release of what I'm building.
Even when your room is
ads, of course. Go figure.
That's the pod. A cooling cover that...
That's what I'm building. It's a little noisy. But the reason why I'm building this is because the person that designed this doesn't have any of these electronics available. So somebody made a remix of it. So that's what that comes down to. Which is fine. And I'm perfectly fine with this. I think it's going to work just fine. I'm actually pretty happy with the overall build. I'm just waiting on the belts to show up. And then I broke the idler trying to put it together because I printed this with infill and the infill snapped. So, oh, of course, I didn't pay any attention. And here's the said part. I mean, I did get one part out of it, but I guess it knocked it off the bed and I wasn't paying any attention when I printed this. This has been in the printer for a couple days now. Yeah, I guess that's great. So now I get to print these again. I'm also getting low on PLA carbon fiber because that's what this is. So, yeah. And I just ordered parts to try to mount the stopper because this is the device that goes back and forth. And on here, there's a stopper switch. So you run PTFE tubes through it, and then it detects filament. So when it runs out, it shuts off the controller, which is kind of cool. I don't have to have it. It's not the end of the world. But, yeah. So when I was building this, you can see what I'm talking about. So I would snap these in here, and then I went to build both sides and snapped both sides of the same side. It's a good idea. Like, design-wise, it's pretty cool. I just have to fix it. So, and this isn't all secured yet. So it's like half built. So, and then over here, some of the washers and, like, the stuff. Like I told you, I printed washers. Cover. But anywho, we're getting somewhere. So I'm going to wrap this video up today. I made a mess, but I at least got the controller functioning, so that's all I care about at this point. I'm happy with that. Jack, donate wire strippers, and Trucker, you owe me like 10 spools of PLAF. Later, guys. Have a good night.